Hi there, I'm Mr. Orr, and today we are looking at, in our algebra textbook, section 8.3, which is multiplying polynomials. Now, the previous section was multiplying a polynomial times a monomial. In this case, we are multiplying a polynomial times a polynomial. So here's an example. This is a polynomial, x plus 2. That's actually a binomial. And this one is also a binomial, x plus 5. In order to multiply these two together, we are going to use a process called FOIL. And I'll explain that in a moment, but what we're going to do first is just use the distributive property. So I'm going to distribute the x to here and to here, and then I'm going to distribute the 2 to here and to here. Remember, distributive property means you distribute each of these terms to each of these terms. That's why there are 4 lines running here. All right, x times x is x squared. X times 5 is 5x. 2 times x is 2x, and 2 times 5 is 10. These two can be combined, as is often the case with the middle terms. So this is x squared plus 7x plus 10. Notice we got a quadratic trinomial out of it. Okay? We multiplied the x times each of these two, and then the 2 times each of these two, and then we got this, combined the terms that could be combined, and we ended up with that. Now, we're going to look at it. Why FOIL? Because when we multiplied this out using the distributive property, we multiplied the x times the x. These are each the first terms in their respective polynomials. So in other words, first term times first term, f stands for first. We then multiplied the outer terms. The x is the outer term over here, and the 5 is the outer term over here, O for outer. Then we multiplied the 2 inner terms, the 2 and the x, that's I for inner. And then we multiplied the last terms, the 2 and the 5, the last term here and the last term here, and that's L for last. So FOIL is a very common acronym, but in fact, please notice that you are simply using the distributive property. All right, now let's take a look at a few other cases. Let's do 3x minus 4 times 2x plus 5. All right, now we have a little bit more complication because we have a number here and a number here as coefficients in front of the x's. So 3 times 2 is 6, x times x is x squared. That's this times this. Now we do 3x times 5, which gives us 15x. We do negative 4 times 2x, which is negative 8x, and negative 4 times 5 is minus 20. Combine the middle terms, I get 6x squared. 15 minus 8 is 7, so plus 7x minus 20. All right? Same result in the sense of a quadratic, a 3-term or trinomial quadratic. Let's look at another case, wherein you have something like this. 3x minus 4 times 3x plus 4. All right? Notice, everything is the same except the signs, which are different. Let's see what happens. 3x times 3x is 9x squared. That's this times this. 3x times 4 is plus 12x. Minus 4 times 3x is minus 12x. And minus 4 times 4 is minus 16. So, here you have 9x squared. But what happens to these two? You have a 12x minus 12x. These two cancel each other out and are gone, minus 16. So the thing to notice here is that if you have 2 binomials, with everything the same except the signs, the middle terms are going to cancel out, and you will end up with only the first term and the last term. All right, let's take a look at one more situation, and that is if you have x plus 7 times x plus 7. They're identical. So I could have written this as x plus 7 squared, but I think sometimes it's easier to see when you're learning these because anything squared is that thing times itself. So this I have shown multiplied out in a sense, whereas this is in a different form, but you will see both forms. Now, let's multiply. X times x is x squared. X times 7 is plus 7x. 7 times x is plus 7x. And 7 times 7 is 49. Combine the two middle terms, and we get x squared plus 14x plus 49. Notice, x squared is a perfect square, 49 is a perfect square. If you take the square root of that 49, which is 7, and double it, you get the middle term. And that is a characteristic of this situation. A number squared or a number times a polynomial squared or a polynomial times itself. And of course, we're talking about binomials here. All right, that may cover what I needed to cover. Let me just see if there's another problem type. Yes, there is another problem type here that we should take a look at. And that is where you have, actually there might be two more types here. Let's look at one that has 3 terms multiplied by 3 terms. So x squared plus 5x minus 1, x squared plus 5x minus 1 multiplied by 5x squared minus 6x plus 1 minus 5x squared minus 6x plus 1. All right, now, it's not FOIL, because FOIL has to be only used with two polynomials multiplied together in which they are both binomials. They both have 2 terms. Here we have a trinomial times a trinomial, but the process of distributive property is still the same. I'm going to multiply this times each of these 3. Then I'm going to multiply the middle one times each of these 3, and then the last one times each of these 3. And we'll get a long expression which will then need to be consolidated by combining like terms. So x squared times 5x, that is 5x to the 4th. Remember, you add the exponents. All right, minus 6x squared times x is x to the 3rd. And x times 1 is, x squared times 1 is plus x squared. All right, now we're going to multiply 5x times each of these 3. So I get plus 5 times 5 is 25 x to the 3rd. 5x times negative 6 is negative 30 x squared plus 5x. Now, in order to stay on the video screen here, I'm going to go down to here for the minus 1. So minus 1 times 5x squared is minus 5. Oops, let me make that 5 a little better. Minus 5x squared. Minus 1 times minus 6x is plus 6x. And minus 1 times 1 is minus 1. All right, there's all the terms. Now all we have to do is combine them. So we have a 5x to the 4th, which cannot be combined with anything. We're done with it. Now, we have we have an x to the 3rd here, and we have some x to the 3rds here. So 25x to the 3rd minus 6x to the 3rd is 19x to the 3rd. So now we're done with those two. All right, we have an x squared here and a minus 30x squared here and a minus 5x squared here. So combining these two, that's a minus 35x squared, plus 1 is a minus 34x squared. Okay, those are gone. Now we have a 5x and a 6x, so that's plus 11x, and we have at the very end a minus 1. I do recommend that as you go through these longer ones, you cross out the terms as you use them so that you know what's been used and you don't get confused along the way. So let's cross that one out as well. We used everything, and there is your answer. And notice it came out very nicely. X to the 4th, to the 3rd, to the 2nd, to the 1st, and to the 0. Okay, I believe that's sufficient for now. But FOIL is a process that you definitely need to know and fully understand. It is critical to moving forward. So if you need to watch this video again, please do. Make sure you understand the multiplying polynomials process. Thank you.